Users should not be informing engineers about a breakage in the product. Instead, users should be experiencing a wonderful product, getting their tasks done, and extracting value out of the software that engineers built. Hello, and welcome to this on-demand webinar hosted by the Plumbr crew. In this series, we'll be breaking down some common problems that engineering teams have and explaining some solutions they can adopt. We'll also proceed to illustrate how these problems can be solved using Plumbr. In today's session, we'll focus on enabling a positive feedback loop for engineering teams. The changes happening in the past few years to the way software has been built has been focused around feedback. Many forms of iterative development have now come to the fore, and these have predominantly focused on enabling a positive feedback loop. Without real user monitoring, once software is built and released into production, the only direct feedback about users' interactions or usage that engineers get is in the form of complaints by users. We cannot rely on users to accurately and regularly report on errors affecting them. Instead, there should be a mechanism that helps engineers become aware of errors quickly. This awareness mechanism must not simply alert engineers to a fault or breakage in the system. The insight that emerges must be both meaningful and actionable. Such systems are not beyond the reach of engineering teams. Simple steps can enable teams to achieve this level of maturity in operations. Let us now dive into the details of each aspect. Once an application or parts of it are deployed into production, it is the responsibility of the engineers to make sure that it is meeting acceptable quality levels. Depending upon the load at which they are operating, applications must not be constrained for memory or complete resources. They must not be throttled for network bandwidth or I/O throughput. Applications must be secure and not exploited for any lapses in security. All this is ensured from the feedback that is gained from monitoring applications in production. The information from the different monitoring systems is what constitutes feedback loops. Information from analytics serves as feedback and conveys how well the product is able to convert users and is a good measure of usability. Security aspects of the application are conveyed using feedback at the firewall and tools that monitor the hardening of applications. Infrastructure monitoring tools provide details, such as how much RAM is being used and the network bandwidth used. In spite of having this varied and granular data, there are some blind spots for engineers. Here's a simple way to think about it. Users may be finding it impossible to use your application, and yet none of the monitoring systems would show any warning signs. As a corollary, a warning from these systems may be issued, but it would not be the cause for a user to experience errors. For an objective feedback loop, these systems fall short of communicating to engineers or engineering teams what a user is actually experiencing. Providing transparency into the experience of the user, therefore, is an important goal of a feedback system. To be able to know what the user is experiencing and to be able to issue alerts when the experience degrades is an important yet overlooked aspect. Let us take a couple of examples. Consider the stack trace you see on the screen. This is an error that is occurring in your application, but is it the cause of a problem that you need to address? The answer really depends on what part of the application you are responsible for. There may be a warning about a disk failure on your storage. Does it really present an urgent problem? Because there may be tens, hundreds, or thousands of disks. Sure, you need to address the problem, but it could also be turned into routine maintenance that you may choose to fix eventually. Production should be centered around what the impact on end users is. This information comes from collecting data about the performance and availability of an application. Performance metrics convey the speed with which the application responds. Availability numbers are used to express the fraction of successful usage of the application. Together, feedback about the performance and availability are objective measures of how an application is performing for users. For a system that is built upon the principles of user-centric design, monitoring must also be user-centric. Data from interactions, sessions, and specific users must be used to drive deeper investigations. Imagine this situation. A user with the ID some1@something.com clicked on the checkout button of your e-commerce website. This triggered a JavaScript error. The trace is shown on screen. As a result, the user some1@something.com was unable to complete their purchase. In this case, the usability of the application is acceptable. There are no security breaches. The infrastructure is operating under normal loads. The database is operating normally. However, when seen objectively, the application has failed to enable the user to complete their task. This should also form the basis upon which awareness is built for engineering teams. Let us now spend a few minutes in building what would be an objective-driven framework for a positive feedback loop from production systems. We'll build this keeping users at the center of the experience. This framework should also serve as the basis for both performance and availability objectives. Let us build this understanding in the context of an example. Assume that there is an e-commerce website that sells books. Let the name of this website be ebook.example.com. A standard technology stack powers the application. React.js is used for the client side. The API backend is served by a Spring Boot application. A MySQL database is used, with an Nginx proxying the API and serving static files. A Docker Compose bundle is the infrastructure underneath binding all the services together. The objective of this application is to allow visitors to search for particular books and purchase them online. You're the engineer who is in charge of mitigating any incidents and ensuring quality levels for this application. What's the first thing you need to be able to do your job? Step 1. Awareness about any incidents. Engineers must be made aware of any incidents in the application. Instrumenting the application and record and report for any failures is an important step in becoming aware of user experience. This awareness could come from looking at lists in monitoring tools. But this awareness should certainly not come from a user complaining about an issue. Step 2. Assessment of the impact. Knowing what is broken is the first part of assessing the impact. It could be a particular service that is broken. It could be an underlying exception that is causing multiple services to break. Assessment of the impact must also contain details about who is affected and in what volume. Step 3. Prioritizing the incident. The insight into what is causing the incident, along with the impact it has on users or usage, should tell you if the error is important enough to warrant the attention of engineers. Based on the insights provided, you should be able to make an objective judgment into fixing immediately, fixing it eventually, or not fixing it. Once you've decided to fix the issue, the next steps focus on aiding the process of finding, deploying, and acknowledging the fix. Step 4. Implementing the fix. Monitoring should provide information of where you should begin to investigate for providing a solution to the problem. Step 5. Deploying the fix. This particular aspect is outside the direct purview of monitoring. It is an important step that you have to take as an engineer. Step 6. Acknowledging the fix. The monitoring data should be able to ascertain that a fix for the issue has been rolled out if no more error incidents contain the same stack traces, services, or interactions. Let us now attach Plumbr, a real user monitoring tool, to this application. This will help us verify the same principles in light of a tool. Plumbr was built to provide engineers like yourself insights from production systems that will help close the feedback loop. Plumbr monitoring can be availed as a SaaS product. You can also have an on-prem version of Plumbr deployed to your infrastructure. For purposes of this webinar, we'll be walking you through the SaaS version. Attaching a Plumbr agent is simple. To monitor user interactions, you add a JavaScript snippet to the head section of your HTML pages. For the purposes of this demo, we'll make an assumption. Let us assume that a user of ebook.example.com writes into customer support. They state that they've been unable to search for a particular book. This indicates that the search functionality is broken on your application. Let us now examine the same example commerce site from within the monitoring tool and the framework that we have built. Let us now investigate to see if we can follow the steps outlined in the framework we established a few minutes ago. The first step, if you recall, is awareness. How can awareness come from Plumbr? Plumbr agents have been collecting data about ebook.example.com. This data is now presented as what you see on screen. This is the summary of the performance and availability of the whole application. In our current example, we assume that a user is having trouble with the search functionality. Is Plumbr capable of identifying this? In the same screen that outlines the availability and provides us a summary of the application, there is a table in the bottom half of the screen in which the errors are listed. We can clearly see that the service related to search is on the top of this list. Step 2. Assess impact. The next part of the framework demanded an assessment of the impact. A general overview of what's working and what isn't, and for what volumes, comes from the summary for the application. Specifically, we can select the search service, and we see that it has impacted over 80 users out of the 200 or so who use the application in the given time frame. This confirms that search has been an issue for not one, but several users, but only one of them wrote back. Similarly, we can get information about the impact of each failure or performance issue in the application. Step 3. Priorities. Going back to the table that listed the most failing services, we can clearly see that the service related to search is on the top of this list. In terms of features, pagination is also causing failures for the users. The impact of search is on a much larger number of users. In comparison, pagination is currently affecting a smaller fraction. This indicates that search needs to be dealt with at higher priority than anything else. Step 4. Implementing the fix. In the next step, which is implementing the fix, Plumbr can help with the first phases. This involves identifying the places in source code where the error is occurring, allowing engineers to speed up troubleshooting without trying to reproduce the error, align operating environments, etc. In this example, here is the null pointer exception that is causing search to break. The stack traces show the line numbers and methods where investigation needs to begin. A quick way of navigating this is by copying the stack trace and pasting it into the IDE itself. Step 5. Deploying the fix. Monitoring or Plumbr does not have a direct implication here. Information from Plumbr can be used in correlating restarts, but that's about it. Step 6. Acknowledging the fix. This is an important part of the feedback loop where Plumbr provides value. Every time we observe an error, we record the place in the source code along with the line numbers, method names, class names, etc. When a fix is rolled out, errors no longer come from the same place. Plumbr data will show that these errors don't appear when the errors and consequently error rates become 0. Plumbr flags the error as fixed and reports it to the user. A simple way is that the error graph stays flat. In our monthly reports, we send out the errors that have been fixed each month and the improvements in impact that it brings. Further maturity can be had from implementing better awareness. One way of doing this is alerting based on error rates. Let us take another look at the chart that shows interactions and errors. You need to know when your application is degrading for a substantial volume of users, and your error rates are consistently on the rise. Here's a configuration from a Prometheus alert. Assuming you need to know about the numbers of users and failed users every 24 hours. You can modify this to represent error rates. Here's a Prometheus rule that alerts on high error rates. You could configure an alert on the Search API if error rates consistently stay above 10% for over 10 minutes. In addition to Prometheus, Plumbr integrates out of the box with any alerting tools such as Nagios, Zabbix, and PagerDuty. You can also configure Plumbr to file issues to Jira directly or participate in ChatOps by sending notification to the DevOps Slack channels. These options will help build early awareness of any issues and help inform engineers before a user sends out a complaint. This early awareness based on availability is one part of the positive feedback loop that you can enable thanks to Plumbr. In addition to availability, you can also examine the performance of application in a similar vein. Plumbr can help identify issues arising due to poor performance and resolve issues that correspond to performance problems. There are many more features that you can take advantage of using Plumbr to help build a mature DevOps practice. The fundamental principle lies in closing the feedback loop from production to individual engineers who contribute to production. Now that you've seen the advantages that Plumbr can bring you, we invite you to try the product and experience these benefits firsthand. Your teams will gain an unprecedented level of transparency into your web applications in production. Head now to Plumbr.io and sign up for a free trial. If you're interested in having a longer conversation about how Plumbr can benefit you in specific ways, you can reach out to us. Thanks for watching.